Hello, hello. Back for day 3.
Hi, everyone. How's it going?
Morning, good morning, everyone.
And I think we're excited to kick things off here in just 1 or 2 minutes. We're going to give people another minute to log on, but I know I'm really excited about today's topics. We'll go through the agenda in a minute, but I just want to say good morning, good afternoon, and good evening to everyone. I've just been blown away by the participation we've had in this event so far. I was telling my kids last night that we had people from over 70 countries show up. So being able to roll into my home office and get on Zoom and talk to people from 70 countries is, I can't imagine how I could be luckier than that. So I'm just excited to be part of this community and be able to connect with all of you again today.
Yeah.
Let's see if we're ready to go here. I think that we are just about ready. So I'm Mark Collier with the OpenStack Foundation, and
I'm Ashley Ferguson, also with the OpenStack Foundation.
Amazing. Okay, thanks for everyone joining us. Thanks again to Ashley. We'll be your MCs again today throughout the event. And to start with, we're going to do something we did yesterday, which is we're actually going to recap a little bit of what happened yesterday, go through some of the Etherpads. And I think to help us do that and kind of refresh our memory from yesterday and maybe catch people up that weren't here, we're going to bring in Jonathan Bryce. So Jonathan, why don't you tell us a little bit about yesterday's recap?
All right, let me get my screen share up here. So yesterday we had 3 interesting sessions where we had the large scale tools session, the HA networking session, and then a software stack session. Are y'all able to see my screen?
Yeah, it looks good.
Yep. Okay, great. So progress already over yesterday. We started out with the tools section, and I thought this one was pretty interesting. It went in a few different directions. People were talking about the different kinds of ways to measure scale, and the different kinds of considerations that might come into what you are trying to scale, and how that might affect tools. The section that I thought was one of the more interesting ones was when we were talking about different bottlenecks, and we had a number of people who shared, I think they were called horror stories, but basically trials and tribulations in scaling different systems. And I thought that was some really good kind of knowledge sharing that happened there. I think the thing for me that was probably a big takeaway and something to follow up on, and we can talk about this more in the wrap up this afternoon, but was around sharing tooling. And there were a couple of different areas where people have shared tools historically. The OS Ops repo was one of them. There were some other tools that were put in there, and it seems like those tools have been the source of ad hoc discussion several times, and it seemed like maybe it was time to dust off those discussions and figure out if there's kind of maybe a more holistic way to look across all of these different tools repos and help people access the kinds of custom tools, quote unquote custom tools, that are being built across these different organizations, so that we can all share in that knowledge. The next session was the HA networking session. I thought this one was very good as well. I thought Beth did an awesome job of driving to specific questions and getting a lot of discussion going. It's probably our most interactive one yet, so thanks, Beth, for that. And here we talked again about some of the different vectors that apply to scaling. Had an interesting discussion around kind of where do you put failure domains, and where's it most cost effective to do that? Should we pay for a lot of redundant expensive hardware, or handle failures at the rack level and trust the software to be able to work around that. So that was a pretty interesting conversation that we got into there. There are some topics that that didn't have time for. So this is one that if you are interested in adding your thoughts, the Etherpad is still up. We did a poll in the third session, which was about the software stacks. And it seemed like people said upgrades and networking were some of their more challenging areas. So maybe go throw your thoughts in networking around where the challenges are, and we can follow up on those later on. And the final one was the software stack section. This one, I think, we had some interesting discussion around the sort of form factor for compute, whether it's bare metal, virtual machines, containers, what the mix is going to be over time, and how to plan for deployment of infrastructure software, but also kind of how to plan for the mix of the kinds of resources that the end users are going to want. I think one of the things here that I noticed was software stack, super broad topic. It seemed like it took us a little while to warm up and chime in. So as we get going today, I think that finding those very specific questions within the different topics that we have is going to help to get all of the attendees and participants active and engaged, and help us kind of finish on a strong note today. So that's the recap. And one last point that I thought was really interesting, Mark, kind of along with what you were saying. Yesterday we had moderators from Europe, from North America, and from Asia, all in one single session. So I thought that was pretty cool.
Yeah, it's amazing to see the participation. I think we're all dealing with the challenges of not being able to travel as much, but there's so many benefits as well. So it's nice to see some of that. So I think next up, we're gonna have Ashley do a quick reminder of how to participate, especially if you're new. This is your first day here. She can give you the rundown.
Yeah, thanks, Mark. Yeah, so thank you to those who have been on day 1 and 2. Those have been amazing. So thank you for returning. And if you're new, welcome. Glad you made it to Zoom. Thanks for going through all of the technical difficulties with us. We're learning as you are, but overall things are going really smooth. So Zoom has been great. So congrats if you made it here. That's the first big step. And then another tool we're using is Etherpads, which is what Jonathan was just scrolling through. So we'll talk a little bit more about how to use that later. So back to Zoom, we've been using the Zoom chat, as you can see. So this is the best place for any technical questions that are topic relevant. So feel free to drop those in there. We'll try to answer as many as we can and direct it to the moderator and whoever's speaking. But also we want you to feel free to jump in yourself. We want everybody here to feel like they are welcome to participate. So feel free to hop into the conversation. But if you're not speaking, please just remember to keep yourself on mute with that button at the bottom there, just so we can, cut out any background noise, because virtual conferences are hard sometimes. So Etherpad, like I mentioned, that is an open source tool that we rely heavily on for a lot of events. It's wonderful. It's for real-time note-taking, used for feedback, action items. So you'll see things in there that moderators might ask for comments on, things like, hey, put a +1 next to this if you're voting for this. So it's a really cool tool that we like to use. And also I would encourage you to drop your name in there. There'll be a section at the top of most of the Etherpads. We have one per session, and it'll say participant, and go ahead and put your name in there and put an asterisk next to your name if you are interested in chiming into the conversation. Just helps the moderators know if somebody would be comfortable being called out to speak about a topic they might have commented on. So please jump in and do that if you want. And then if you need help at any point that's, not relevant to the conversation, but you might need help logging on at any time, feel free to email events@openstack.org, and we have people waiting to help you out with that. Like I said, if you have a question about anything relevant to the topic, ask it in the Zoom chat, or you just want to say hi, feel free to drop that in there. And then we also have a tips and tricks Etherpad that was emailed to you before the event. So we'll drop some links in right now to those. And as a friendly reminder, this is an OpenStack Foundation event. So we do abide by the OpenStack Foundation Community Code of Conduct. So please be courteous, respect yourself professionally, and please respect each other. And if there is a violation you need to report at any time, feel free to visit that URL at the bottom, openstack.org/code of conduct, and there will be instructions on how to do that there. And with that, I will turn it back over to Mark.
All right. Thanks, Ashley. You know, by the way, Ashley, if you wanted me to go on mute, you could just ask. You don't have to make an entire slide and present it to everybody. It's a little passive aggressive, but anyway, I'm not on mute now. And I just want to say thank you again to our programming committee. Amazing work. They helped pick out the topics, and several of the folks also have been part of moderating this event. So amazing job. Next, I also want to go ahead and thank the sponsors. So we have a number of sponsors that made it possible for us to do this event today. And we can get the slide. Yeah, this is these are the folks. These are the companies that really provide the financial support that we need to put on the event. And we're able to do it for free for attendees, which is always nice. I think that's one of the many reasons we're able to get even broader participation from around the world. And speaking of which, I also most importantly want to thank all of you. So we had people from over 70 countries, and this is just something that is really, really important to me for us to be able to be accessible, inclusive, and again, making the trade-offs on a virtual event. There's a lot of stuff that makes it trickier, but it just makes me so excited to have people from all over the world here on the event. And if by any chance your country's missing, let us know. We'll add it to the map. This is based on the Eventbrite registration system that gives us a map of where people are registering from. But we had over 800 people register in 70 countries. So thank you to everyone who is participating. This event is really about giving you all a space to connect. And so that's going well so far. Let's take on day 3. So for today's schedule, we're going to be talking first up about bare metal with my good friend James Pinnock from Verizon Media, who is right there on your screen, getting ready to jump in. He's almost James. And then we're going to be having an edge computing session, and then we'll do a wrap-up session. This is going to be longer than the one we had the last 2 days because we want to actually get into some more details. We have dedicated time on the schedule. And we have a couple of breaks built in there so we can catch our breath in between. And so, with that, the last reminder I'd like to say is that we have some upcoming events after this one wraps. So there are 2 more OpenDev events. Each of those are 3 days. So July 20th through the 22nd, which is, hardware automation. And James Pinnock is actually involved in that on the programming committee. He has a lot of hardware to automate. If you want to ask him all about it, he runs an incredibly large cloud for Yahoo, aka Verizon Media. We also have containers in production, everybody's favorite topic, containers, but actually running in production. So not just kicking the tires in August. So you can register for those. They're also free. The registrations are on this page here, openstack.org/opendev. So please go ahead and register for those if these topics are interesting to you. We'll start getting Etherpads populated so people can get ready and gear up as we head into July and August. And then the Open Infrastructure Summit will be in October. And we're just opening up CFP now. So that's the stage we're in for that event. So it's a little further away, but the CFP is really, really important. Call for presentations. So if you have an idea of something you'd like to present at the Open Infrastructure Summit in October, now is the time. It's actually just going live right now. So please go on to cfp.openstack.org. We'll be putting more information online as we get closer to the event. But right now, the CFP tool is open. That's the phase we're in for that event. It's the biggest event we do every year. So go ahead and get excited and get prepared and start thinking of your ideas for the summit. All right, so with that, I am going to turn it over to James Pinnock to talk about bare metal. He's going to be our moderator. Please get involved, ask him hard questions, and put him on the spot. My good friend, James Pinnock, take the mic, sir.
All right. Thanks, y'all. Good morning, afternoon, and evening. Let's go ahead and kick off. I can go ahead and share the Etherpad. Aaron, could you put up that poll?
I can, 1 second.
All right, thanks.
We love polls.
Should be up.
Excellent. I did not run ahead to make sure Zoom could. Actually, is someone else able to share the Etherpad? Apparently I have to quit Zoom and rejoin for it to be able to share my screen.
We've got it, James, no worries.
Thanks.
Yeah, we've been running into a few of these, so we're ready.
All right, thank you. Okay, so let's go ahead and we'll keep the poll up for a little bit and we'll start talking through a few of these use cases and then we'll come back and discuss the poll results. So starting out with the use cases, what are your folks' use cases for bare metal? I see we have at least a few people that are doing cloud infrastructure for provisioning, and then bare metal instances directly for clients, and then traditional data center management. So for the cloud infrastructure provisioning, are there folks here that want to talk a little bit about what they're using it for? I can start by sort of teeing off what we do. We do have quite a lot of bare metal instances, and we have everything from sort of more traditional data center workloads, which certainly make up the bulk of our fleet because we've been around a couple of decades, and so we do have quite a lot of hardware still in those areas. But we've also been building out new cloud infrastructure. So we've got a little bit of everything, from building, we use Nova with Ironic to provision 100 and something thousand bare metal machines, a lot of which, like I said, are the traditional workloads, but we also use it to manage our OpenStack VM installations, which and then both things are available directly for our users to consume. Plus, we have a more modern OpenStack infrastructure that we've been deploying recently. It's our new cloud native thing. So what are you all using it for? Does anyone want to share what they're using?
Yeah, Prakash here. Yeah, we do use in bare metal, specifically invocation through Ionic, using Metal Cube from Airship. That's the one use case which is really interesting, and the possibility of using bare metal either through Metal Cube has again two modules. One is bare metal operator, the other one is Ionic interface. So either you can use the Ionic or you can replace with any other bare metal invocation, like Starling X does something different. So these are the possibilities, and definitely it's a good one, specifically since it of course deals with a bit of a container besides the bare metal, and very interesting. These two projects in OpenInfra have been really instrumental in leveraging the bare metal. Thanks.
So that was interesting. So it's you a little. It sounds like you actually use a few different things, but I thought the interesting one there, especially, was that you're using Metal Cube with that's Kubernetes with Ironic, right?
That's right.
Excellent.
1 second. Did I mute myself? Sorry.
Excellent. And then some folks out there, it looks like what you're doing is you're actually provisioning bare metal instances on behalf of clients. So you have users and consumers, and you're provisioning bare metal on behalf of them. Does anyone want to talk about what they're using, how they're consuming that?
So this is Beth. I could talk about our bare metal at the edge, which is of course primarily driven by the fact that you want to minimize the resources that you use for the underlying infrastructure. So bare metal is kind of the obvious one of the ways to reduce that footprint. So we're using something, it's actually a commercial product that is built. It's OpenStack, and then I'm not actually sure, they're not using Ironic. I'm not sure what they're using underlying to orchestrate it and build the shim. I call it a shim, the underlying hypervisor.
Awesome.
So,
Okay, cool. Yeah, so the edge use cases, those are really interesting, since I think, you know, edge is very much top of mind for a lot of deployers right now.
Right.
So then your team does a lot of work. Or part of what you're doing is you're deploying bare metal onto the edge, and then you're using that to deploy like containerized or virtualized workloads.
right. Yeah, they're virtualized right now because we'd love to do containerized, but that doesn't exist yet.
Mhm.
Yeah, but the main reason that we're doing it is because we want to reduce the footprint as much as possible. But yes, the workloads themselves are not bare metal. They're on top of the infrastructure. But we ran into an issue, I guess last year. You know, we were going to upgrade, and because we had added some significant functionality into the underlying infrastructure, and it was and I've talked about it. I think I talked about it on Monday. There was a significant problem in that it took us several hours to rebuild each one of the boxes. So what it should have been, you know, you download the new image and you know, reboot and you're done. But that wasn't, unfortunately, the way it had to be done. So we had to download the image and then rebuild the box, you know, and which took, you know, that meant that we had to put in a maintenance window of like 3 or 4 hours, which is tough in an edge environment,
Right.
because it means that you're not completely connected to that environment during that time. So there's a risk that we lose connectivity and have to
Right.
send somebody out to take care of it.
So this is a model where you're going to image machine on the edge, and there's no local cache for the image. So it has to pull that image down over the network from a site that could be hundreds or thousands of miles away. And so just the latency pulling down those presumably hundreds of megabytes or even some gigabytes.
Actually, a couple of the images are gig. They're like a gig or two. So yeah.
That's a problem we've seen as well with some of our stuff with, and so we've been working on some different ways of addressing that. One of the things we're looking into, well, that we've actually done with some of our bare metal stuff is in our edge sites, we actually can pixie boot over the network a local machine that does a secure remote boot. And that machine then becomes a local image repository, but it's all storing the images entirely in RAM. And then other machines then in that edge site, they can pixie boot off that first machine. The interesting thing with that design is for our model, it's different than like the larger telco. You know, we're doing like content caching, and we're focused entirely on providing accelerated like user experiences for basically web content, but we need to do it in such a way that we're ensuring that no user data is being put at risk. And so for us, the acceptable risk is that all these machines are basically diskless, and if they reboot, then we have to wait for that first machine to reboot over the network, and then all the others can reboot. So we accept that all the machines in that particular version of an edge site, we might just say, okay, well, they're down for hours now in case something happens. And this is done so that if somebody were to go into this edge site and like steal the hardware, they couldn't take any user data off that are compromised or security. But that's much different than like a telco use case where you actually need to be providing like a communication service that's persistent.
Right. So there's the rub, right? You're providing a network service. You need to upgrade the network service, and you have to take the network service down to upgrade it.
Yeah. What I like about what you brought up there is it shows the very large spectrum of use cases for bare metal, right? It's one of those things. It's like public utilities. You know, a lot of people don't appreciate the water company or the power company until it goes out, and then it's just like a fundamental part of the universe has disappeared. And so they're just so used to bare metal being a thing that is handled for them that they don't even notice it. But it really shows that there are for all this focus on really interesting, far more interesting, like workload management systems from VMs, containers, and functions, that a lot of people do turn their nose up at what is really the foundation of it all, bare metal. And so I think that's really interesting. Let's kind of moving on in the doc here. Folks, where do you see your use cases evolving over time? Are you seeing, we've talked about the edge and far edge. Is there anyone else out there that like recently you've been seeing newer use cases that you certainly didn't anticipate? And feel free to unmute and join in if you'd like.
Yeah, one, I don't know whether it's new, but I do see use in ONAN for the 5G physical bare metal being used for the development of 5G functions. So when you do some kind of a distributed or disaggregating the functions, the tendency is to use bare metal. Maybe with containers, without containers, but that's the way at least current development is going on in open source community, other open source communities.
Interesting. Okay. And certainly, so sounds like containers and maybe about the abstraction from bare metal, so that your use cases are. Does that mean that maybe some of your bare metal use cases are simplifying over time, and that the more complex layers for the things you were demanding of bare metal are moving into the things like containers? Or do you feel that? Sorry, go ahead.
So I don't know, maybe that is because when you deal with the lower layers, especially layer 2, layer 1, then the composing the stack disaggregated makes it easier to deal with networking if you are in the bare metal. But that's the current state.
Prakash, could you talk about that a little bit more? Because so as I'm thinking about it, bare metal brings up the the perpetual cycle of disaggregated hardware with with integrated hardware, and so you're more dependent upon the hardware. So
yeah, that's true. So initial all 5G functions are currently being viewed as depending on the networking, the storage, the compute, and so they tend to work towards simplicity, and that could be because it is in the early stages. Now that is my interpretation, but it could be maybe because of more to do with the performance, more being able to directly deal with bare metal, especially acceleration. And so because VM and containers both do not have all the feature parity, and that could be one reason. But I'm still struggling, because if you look at XPUs, I mean the GPUs, the FPGAs, so those drivers are not really available for the situation where they would like to get it. And therefore, I believe the need for doing that is more so in the newer functions which are related to radio, which are related to what you call the edge. And that's what I understand, but still I may be wrong, off target. Essentially, I'm trying to still understand why that.
So largely my perception is that it's occurring because people want or need the performance. They feel that containers are an easier way to move forward. The cost of that is actually that your environment's networking is no longer abstracted. It's no longer something that you don't really have to worry about. It's something you have to absolutely focus on, and it becomes a huge configuration bottleneck in terms of how do I get from point A to point Z with a deployment and environment. with a network that very few probably even understand. And I mean like the physical wiring of the infrastructure down at the server level.
Yeah, that's actually interesting point. So that's the trade-off is that you've got the trade-off between the abstraction and the advantages of abstraction, but also then the perceived like performance delta. So like bare metal, you certainly have higher performance, but you also then lose some of the higher order functions and some of the interesting tie-ins you can get with infrastructure, which actually wants me to take it to one of the next things here. I'm seeing some really good stuff coming in this teal color here. For the folks writing that, I see infrastructure as code for bare metal and VMs. I really like this one, so Terraform for both. I actually really like that because that's something that we're finding is important for us too, is the ability to have some kind of cloud orchestration for bare metal and VM. Basically, in our environment, something that I've worked towards for a long time is to be able to present our infrastructure as really that bare metal is just, and VMs are just like different size flavors from each other. And that's one of the reasons that we use Nova as the entry point for our bare metal, is for our users. We're trying to train them that a VM and a bare metal are really just two different sizes of a thing. Because for us, we have kind of an addiction to bare metal, and we're trying to move people off of that and move our users into things like VMs, containers. Oh, John, do you want to talk a little bit?
No, yeah, I can do. I'm +1 on everything you said, really. I guess we're seeing a lot of, so we work a lot with, HPC centers that have got massive Slurm cluster and want to replicate the same thing, but without all the manual crazy. So it's kind of, and to actually start getting to the point where they can carve off subsections of that for people to do, like simple things that you can do in infrastructure code. Just for, well, let's have 2 clusters, one that's half the size and dedicated to customer X. Like once you take the hit of actually fully automating your stuff, then you can kind of start doing those things. But yeah, the VM bare metal distinction hopefully kind of goes away. Although I'm agreeing with everyone saying there's a performance versus abstraction trade-off. Certainly one of the things for me that always keeps coming up is live migration. And that's kind of an application thing in many ways. So like at some point you need to decide whether you get to choose when you flash the firmware on your host independently of what the VMs are doing on top, or whether people actually know it's a physical machine and they take the hit that one day you'll come and tell them that it's time for them to get off that.
Yeah,
and
that applies and that applies triple in the edge.
Yeah, no, that's very true.
One
yeah, I
other
guess
thing.
it's
Yeah, go ahead.
I was just gonna say, it's just that, yeah, it's that performance abstraction trade-off, I guess.
Yeah, abstractions, when you talk about, we do find the API level abstraction for physical, because you need to discover the various drivers, and that there is one API by Intel which is trying to harmonize across with NVIDIA GPUs on one side and other FPGAs, and so they call it XPU, and then one API directly talks to the devices, discovers, and that's something which I am seeing as one of the evolutions, and that could take some impact on the bare metal in near future. Like GPU CUDA is the way which NVIDIA had been doing, and so they have brought something called SYCL for the OpenCL, which is a concurrent processing, so that you can do multiple, like if you want to provision hundreds and thousands, then that could be a multi-threaded option, and that's evolving. And we do see in the data centers that how fast can I create a VM, or how fast I can get a Redfish API to boot a bare metal and eventually this is going to be for the more on the larger scale deployment, but it can also be used for the edge, because then you can do it remotely. Plus, the early days, if you remember, when VMware started early 2000ish, we used to do P2V and V2P, but I don't know whether we can do equivalent of P2C and C2P in this new environment. But those are some of the ideas which will pop up in the market. I don't see that history doesn't repeat itself, but we
So-
will look forward to this.
Yeah, I mean, I've noticed recently using like for one example, the CentOS Cloud images, like they out the box support like InfiniBand hardware these days to a surprising degree. So we've kind of seen a bit of convergence in the fact that, so if you think about SRV and PCI pass-through, we've kind of broken some of those abstractions in the VM world anyway. So you actually need the drivers in there to actually access those raw GPUs that we're passing in. So I think all you say is true, but I think we've got the same problem in the VM world as well. In the VM world. I also need to pick more shirts that cause aliasing artifacts. I have a perverse want to do that. Anyway.
I think a lot of
Yeah.
differences end up coming from the fact that an application ends up getting built a certain way and has certain operational needs to fit inside an environment. So I think where we start seeing the need for I need to use a container instead of I need to use a VM is largely the style of orchestration and the style of application architecture combined with that my entire process to get to that point.
Right, and I think a good like a good sort of strawman example of that could actually be like we've got folks in my team. They're working on containerizing even how we deploy OpenStack and Ironic and our environmental management system. But for our VM stuff, even though we want to containerize most of the control plane, for example, the hypervisor itself is not something that right now, that workload is not something that we're going to containerize just because of the complications between where you run QEMU versus not.
I was going to say, we certainly, so for Collar, so we tend to use a lot of KOB with Collar Ansible, and that does do that containerization of QEMU and libvirt and OVS.
Oh.
So that works. It's more a case of the fact that the containers are probably more privileged than you would want, but it gives you the advantage of having the images that you push out on top of the base image, which is nice. So you have to have a matching kernel, basically. Yeah. So it's well worth looking at the Collar images. They've tackled that. So what we generally do is we use Bifrost to do all the hypervisors and the control plane. So that's standalone Ironic. So that's what KOB deals with. It does that. So that's all containerized on that bare metal. And it also has, KOB's got a nice way of which it can then start enrolling the Ironic nodes into the overcloud Ironic for you as well. So you get that split between controllers, hypervisors, and Ironic bare metal nodes. So you've got, it's worked through all of that problematicness.
Excellent.
So it's definitely worth a look there.
Hey, J-Roll, are you on?
Yeah.
J-Roll, okay, good. Let's steal what John Garbutt's idea. Let's do that too.
That's what I'm here for.
Awesome.
Talk to Mark.
Always steal John's ideas.
I'm stealing everyone else's, so you know it's all recycling.
One big, yeah, exactly. Excellent. So kind of moving on to one of the next things. So folks that, in terms of like the next evolution of these use cases, do you feel you have all the tools you need? Are there things you think that are missing, or that you have? So do you have anyone have anything really interesting that they're building that they'd like to share?
Sure, I like to see some discussion on bare metal with respect to switches, because bare metal doesn't mean that necessarily it is all servers, right? So you do have white box implementations of switches which are also coded as bare metal. So how does anybody come across or has anybody used bare metal switches and loaded the operating system and are using in field? Any of the operators? Like
Let me
DNOS?
confirm a yes on several fronts, actually. So we've made great use of that with Ironic's Nova and Neutron integration. Actually works really well. So you can go through the provisioning network into the tenant network, back into a cleaning network that's all separate. We've used a combination of NGS, networking generic switch. So that's quite good at SSHing in, like over like a Paramico kind of thing. Also using a little bit of Ansible networking, which I guess Julia, you can probably talk to much more than me.
I see. That's interesting.
It's pretty effective, and it's been useful for for those cases I'm saying, like you're dealing with all the VLANs and all that mapping that's now inside the OpenStack abstraction, as it should be, to get that similarity between bare metals and VM. I haven't dug into things like the like bridging between VXLAN and VLANs and all that kind of.
Are there any specific agents you are using there for the switch configuration? And
yeah, networking generic switch and Ansible networking, slightly depending on which switch vendor supported and where. There are some scale limits, but they've all got their solutions around that. So some switches will only have you to have some of the old Dell switches, for example, only let you have 5 SSH connections at once because they've got a poor little processor there that only wants to do that. But as long as you can actually use NGS has got like a locking system. It can use I guess it's etcd or whatever to supports, I guess. But it has the locking system to make sure that you can only do 5 concurrent connections at once across the 3 controllers and all that kind of jazz. So it's been pretty effective. Although, it is another point of failure, to be fair, like there are ways in which you can get into funny situations, but just with anything, just hardware always seems to be, it's hardware.
anything about the inventory in that respect? Bare metal inventory, if it is switches versus servers? Anybody has come across any? Like
What do you mean by inventory?
So what happens is you do discovery, right? Once you do discovery, where do you manage to keep those configurations? Is it something like in
yeah, you have to keep them in controllers. Yeah, you have to keep. Yeah, it has to be centralized management.
Okay, so like you have one app called ANDI, active and available inventory, where they put everything.
Yeah.
So similarly in Kubernetes we have HCDB, and here we obviously put in MySQL, I believe, in OpenStack, but still could be any other.
Yeah, it could be any.
So
doesn't matter.
We have done with quite a few customers. We're trying to do like relatively zero-touch provisioning. So we actually tend to use, so the KAB I was talking about, we tend to discover the hypervisors using the Bifrost inside there, using inspection. So all those machines, once you power them up on the right network, will do inspection and give all the LLDP information back to the central Ironic, and you can move from there.
But John, how many
you want?
Yeah, I was going to say, I remember having a discussion about this because at the edge, we were talking about doing a bring your own hardware type solution for our customers. And we quickly realized that it was very fraught because absolutely you have to do discovery, but you also immediately have potentially hundreds of accommodations.
So when we've been doing the large build outs with customers, we've been basically working with ensuring that the vendor ships you a compatible configuration for doing this kind of thing. So if when you take your server out the box, it's doing DHCP on its out-of-band management interface, for example, that gives you a lot of benefits rather than taking it out the box and them all having the damn same IP for DHCP, for the out-of-band management. That's unfortunate. I think there's a fun story in our blog about how you can get around that, but that was only that was like 2 racks rather than anything large scale, because heck, that's hard.
John, do you do in-band or out-of-band discovery and introspection?
Generally in-band.
Okay, so then you obviously need to have the minimal setup in order to be able to do it. So
need to
that
know-
means that whatever the hardware you bring in is already at least partially pre-set up for you to be able to do it. It's not just the DHCP IP address.
what he's saying is that a compatible SKU is basically order delivered to the
Yeah.
site. It's connected, it boots, and that's where that power of that in-band discovery exists. Is where it doesn't. You don't need to know anything about the machine otherwise, because it'll get populated and stored, and then whatever human or software process you want can take that data from there and then do the next needful steps.
Exactly that. There's a point where, so I've had these conversations a few times, and it depends what you fix in time, right? Often when we get equipment sent from vendors, you can actually ask them for a list of what they've sent you in terms of MAC addresses, potentially for the out-of-band management networks. So if you've got, and you know that you've got so many ports populated on your switch, physically speaking, so if you're like fully populating your switches, what I'm getting to here is if you do zero-touch management, you don't want to have half of your rack turned on, right, and not notice that the other half hasn't done something. So you do need a list of what you expect to see versus what you've actually discovered, right?
You're actually treading in some waters here that are really interesting for me, because these are something that we also rely on getting. We buy just whole whenever possible, just whole cabs of hardware from our cabinets of hardware from our vendors, and then we do still get quite a lot of gear loose that we then assemble into our own cabinets. And then when we get the hardware from vendors, we do get a list of MAC addresses with them. And one of the things we found, what's interesting, and I'm curious if anyone else has ever run into this, is when you're buying enough hardware, when you're buying like hundreds of thousands of machines, we will get some where they'll come from the vendor where actually multiple machines will have been accidentally burned in with the same MAC address, or where the MAC address is actually incorrect in the list they provide us. And that can send us on a merry chase through trying to sort these things out. And it certainly makes the in-band inspection a little more difficult, but that's something we're trying to work towards. Is this my sort of like grand vision, at least for bare metal? One of the big pieces of it I call wired up and walk away, where we want to get to the point where a cabinet can come into the data center and we just trundle it out onto the floor, drop the legs, plug it in, and then our site ops personnel can just walk away, and then have the the discovery system discover the nodes, boot them, inspect them, compare them against the purchase order, and then and only then, if something is wrong, call our site ops personnel back. That way our site ops people can really focus on just only dealing with more interesting problems, right? Only deal with things that are broken. We're still a long ways off from all of that. We're working towards it, but I am curious if anyone has started to build any of that automation and actually have that fully automated end-to-end life cycle.
I've spoken to a couple people that have achieved that sort of end-to-end fully automated life cycle. I guess there's two problems. One, there's getting your vendor on board and actually driving them to always delivering a consistent inventory and list, and not having those snafus with flashing MACs. And then there's also getting the entire tool chain in place so you have that in your data center, and you can have that. And usually these projects take a long time. So unless there's a good, strong corporate sponsor, sometimes they end up getting killed because, oh, we can just send people onto the data center floor and do it. And it's not the right answer, but it happens, unfortunately.
Right.
So we're working at the moment with a project with Cambridge to try and commission the new half of their supercomputer. So we'll make sure we blog about how we do that, or how it doesn't work.
Awesome.
I would call out the vendor, but they're on the call.
So
you know who it is.
Yeah.
Ouch.
So speaking of vendors, and actually part of, so that I think kind of ties into something else. So in terms of building these systems to get hardware into the data center, one of the problems we've seen is that we have a team that's always evaluating different hardware configurations. They evaluate how our application consumers are building their stuff and trying to find what are the right mixes of hardware to satisfy all these things, while at the same time trying to then limit that to a reduced number of different hardware platforms. Say like, oh, well, we need 5 or we need 10 hardware configurations this quarter to satisfy all the use cases for organic growth this quarter. But we also buy each of those configurations is satisfied by a number of different vendors. So this means that we have, you know, at a minimum 40 new flavors every quarter, but practically speaking, we have many thousands of flavors. So different vendors, different chassis types, different drivers. And I'm wondering how many other folks out there struggle with things like IPMI working consistently across their fleets. Like, we're not on Redfish, we're still using IPMI. Like, are we the only ones out there that will see situations where we can build a machine, deploy it on our data center floor, and it's for certain vendors? By the way, most vendors have at least some hardware that does this. It's not just one. But we can deploy this thing on the data center floor, and within 5 minutes to 5 months, some of those machines, the IPMI BMC interface will stop working. And then someone has to go and physically reboot the machine to get the BMC back. Has anyone else experienced that?
Yeah, that's pretty common, and at an edge, of course, it's even worse, right?
I was going to say +1. I think we've been working with a lot of customers that have gone to the point of they've got smart PDUs, so that you've got a backup, so you don't actually have to go to the rack.
I was worried about that because yeah, we used to use the smart PDUs, but they're actually really expensive. That whole infrastructure from smart PDUs, and many of them only have an RS-232 interface, so then you need RS-232 like serial concentrators, and then which is even more cost. And the ones that are Ethernet enabled still is very expensive.
I think they were using Ethernet enabled ones, but yeah, it's a choice.
Right.
It's got a cost.
Yeah, it is. No matter what, it's a very expensive solution. And if you think about it, IPMI is really old technology at this point, right? It's what, 25 years old.
I guess what I have found is that there's very few servers where it doesn't work at all. It's been flaky, but it's you kind of have enough usually to get Ironic to work. I guess is what we found.
But did you have the same problem with Ironic also, John? You know, in terms of Ironic stop responding after some period of time?
I always remember there's the odd node that comes across that does something funky. And I wouldn't say it's any particular vendor. I'd say it's just generally that's something that happens occasionally with Ironic. And to be fair, actually, Ironic's reporting and logging has been, I think, reasonable enough to see that that's what's going on.
Yeah, but you mentioned that you had a problem specifically with IPMI protocols. I was wondering if you go to the Redfish protocol, you have the similar problem. Of course, Ironic being in the middle, it can mitigate it and take appropriate action so end user does not see it, but that's slightly different angle.
I see what you mean. I don't think any of the problems have been persistent, if you see what I mean. It's just that every so often out of our management's gone a bit funky. I wouldn't say there was. I wouldn't say we've done it at enough scale to see that there's a pattern apart from what James was saying. Really, that we've seen stuff do strange things. But it maybe deep down, I'm a software person, and I expected the hardware to do strange things. So it's probably my fault.
I think that's basically the best advice I would give any like burgeoning bare metal operator is to expect that the hardware is going to do some weird things. And admittedly, I don't have any experience with Redfish just because with the downside of the running large, like sort of hyperscale infrastructure is that you start having to solve for the lesser common denominator. And so for us right now, like, to Beth's earlier point, Redfish or IPMI is pretty old technology. And for us, we really only got everything predominantly switched over to IPMI in 2011. That was really when we started hit a large double-digit percentage of our fleet was on IPMI. So it just takes a long time.
What was it before?
It was actually smart PDUs everywhere.
Oh, okay. Well, that's funny. Okay.
Yeah, I know. The irony is not lost on us. We were like, all right, we'll get rid of these old things, and now it's like, I wish we still had those. That would be great.
It is ironic that the hardware, I mean, there's a whole lot of hardware, BIOS and IPMI that is, it's so old and it's almost impossible to replace. Because every time we come up with something new, it's like, oh my God, all this other, all this installed base is still out there that needs to be supported.
Yeah.
So
And
how
actually,
about,
go ahead.
how about the use of IPv6 with link local, so you don't have to do all this cloud in it and just do virtual media or something? Combination there.
That's an interesting question. Is anyone use it like with Slack or?
There's multiple questions there, so we should probably tease these apart. It sounded like Prakash was asking about using link local with virtual media. And one of the problems that might be there is you actually can't cross the router. You have to be on the same physical broadcast domain.
Oh, right. So yeah, that's an interesting point. Because for a lot of folks, like so Prakash, like, is this something that you're starting to use in your environment, or you're looking
No,
towards?
I'm just thinking. I'm thinking aloud. Why that we started good old times, Kickstart, Jumpstart, and so many things. And one is at the level where we need to reach, where we have at the BIOS level. The second is OS level. So BIOS level, if it can cover the OS level together using virtual media, that could be an option, because you don't, whenever you do a cloud init, you have to look forward to getting something from somewhere, right? It could be image, it could be something. So if the media itself is part of the firmware, which used to be the older way, right? We used to have everything within the BIOS itself or within the firmware.
So are you suggesting basically attach virtual media that is the operating system?
Yeah, virtual media, if it becomes the default part of the system board.
Okay, I can at least speak from Ironic's perspective, and that was partially what the intention of the storage interface. But we've also seen more adoption and more use cases for virtual media for more ad hoc operations or supporting deployment in general. So it's, I guess the thing, going back to Pennick's comment was, or about, you have to support the least common denominator. In many cases, people want to use the 10-year-old piece of hardware for their lab and testing, and the same techniques are not going to work. They're going to run into firmware issues. V6 isn't going to work. All sorts of things that we would want today if I was building a brand new data center with bare metal cloud, and it's always going to be an experience, and you have to have identified your least common denominator and what path you can take.
Somehow I feel that the industry standard bodies have not really addressed that. Even HC shied away from defining anything on the physical side of it. And
I do agree with some of that. I think part of it is also you get in situations where a lot of new hardware feature development is probably driven by customer contracts. So if a customer wants X, Y, and Z special feature, they're probably paying for that. And so everyone might end up getting that special flavor of the special thing, and it might still not be generally applicable or really completely usable for other things outside of the special case that they have.
yeah, I think there is scope for improvement, a lot of improvement, especially even at the motherboard level or the board level, whether it's out of band or in band. Definitely redesign is called for at this stage with all the changes in the hardware and the firmware capabilities, basically.
Yeah, and I think that would be an interesting thing to work with maybe the user story group to see if maybe we can get like a kind of council of different vendor providers together and see if there's some opportunity there. And I just realized we're running low on time, which is regrettable because I feel like I could easily talk about this for at least another hour with y'all because I've been really enjoying this. I did want to spend a couple of our remaining minutes to talk about lifecycle management. So something that we're looking towards is really covering kind of the cradle to grave life cycle for all of our hardware, everything from when it comes into the data center, and we actually talked a little bit about that sort of wired up and walk away. But other things that are really interesting to me are once we reach our projected end of life point for a hardware platform, usually our models usually show that about 3 to 5 years, somewhere in there, is about when it's time to start to retire a machine. And that has to do with just in terms of like ongoing maintenance costs start to ramp up after a point, as well as in some cases with bare metal, the power consumption of that node is so much higher than newer machines that are coming out for a comparable performance point that actually makes sense to get rid of the old hardware, resell it, and go buy something new. And so for this, I was wondering, has anyone actually done any automation with the full end-to-end lifecycle management? So where, when the machine comes in, you run some kind of burn-in process, it then gets turned over and consumed by users for a long period of time. And then at some point, and this is probably most relevant for the folks who are using OpenStack with Nova and Ironic, when the consumer deletes their instance through Ironic or Nova, have you done any automation so that once that instance is deleted, it actually gets flagged as, oh, you know what, this is an old machine. Don't actually return this to available pool of hardware. This is something we're not doing right now. We do. Oh, please.
I was going to say you probably want to upgrade Ironic then. We have the last half of that already in Ironic, and the wonderful folks at CERN have been talking about posting some burn-in stuff to help facilitate ensuring that the machine is in a good, healthy state before it gets consumed.
That's awesome. Ruby, let's if you're on here, let's upgrade Ironic.
Yeah, I don't know if Arne's online, but certainly there are gradual filling in all the gaps, getting the burn-in done, but also looking at things like a benchmarking cycle to try and pick up any bad parts that are underperforming. And then equally at the other end, a retirement cycle with clean and a special state for that. I think that's in Asuri, if I remember rightly, but Arne could confirm or Belmiro for definite.
Right.
It is
so basically what we...
Go ahead.
So basically what we, like when we started with Ironic, we basically started like almost everyone, I guess, with the provisioning part. And then we're working our way to the two ends, which is basically towards like delivery and auto discovery. So what we have is like we have benchmarking already. Next up is burn-in, and we're leveraging the Ironic framework and actually in order to do this, like CPU burn-in, memory burn-in, disk burn-in, and so on. And then the next step after this will be, which is like in time coming before the auto discovery, but we haven't done this yet. And on the other hand, on the other side, we have introduced a retirement flag actually into Ironic. I think that comes with Osuri, where you can actually flag nodes as being retired and they won't be available anymore. And what we also do is like when we have servers that are not used by or consumed by services anymore, so they're too risky to run like serious services on. With Ironic, we can relatively easily hand them over to the batch team, which just runs batch services on them that can, like if the machine breaks or not, it's not that critical. But yes, but we're trying to use like Ironic basically from the start to the end, and we're still like trying to push and replace all the tools that we have built over the past couple of years.
So Arne, quick question on the burn-in bit. Is there a specific Ironic feature you're doing for that?
So basically what we do is basically very similar to what we do for benchmarking. We're reusing the cleaning framework. So we introduce cleaning steps. So we have a cleaning step that's called benchmark. And basically what it does, it launches the nodes, downloads a container, and the container basically knows where to get its configuration from, and then basically does the benchmarking, and the container also knows where to send the benchmarking results to. So basically it gets like an Elasticsearch endpoint and stuffs all the benchmarking has done into this Elasticsearch endpoint. And we will just do something very similar for burn-in. The burn-in step will be, however, would be split into multiple smaller things. So you can actually, like when you have the CPU burn-in and it breaks, what you want is that the node basically freezes, and that, well, it freezes, it stops at that situation, stays on so that people can log in and actually check, rather than, okay, it failed, we move on with something else and you have no idea what actually happened, or even worse, switch off and you lose the state. So burn-in will be also like steps in cleaning, but individual steps. But basically we're leveraging or misusing the cleaning framework for this.
Well, that sounds like a good use. So you get a clean failed for the burn-in step, basically.
Exactly, and then like the team that's actually like doing all the the procurement team, which is actually and the installation team that does all the installation, they can actually then see, okay, which nodes are in clean failed and why, and they then go in and check these specific nodes. Beforehand, it was like we had our own handcrafted image that the nodes were actually booting into, and then they were scanning basically log files to like see if there's something wrong. So some nodes that peak out. And similarly, what we have introduced or pushed upstream lately is introspection rules. So like very early on, even before we do the burn-in. So if you come like from the end, you do benchmarking, burn-in, and then at the beginning you do like introspection. We have introduced introspection rules which have a scope. So you can basically per delivery define, okay, how many CPU cores does this delivery have? How many disks, how much RAM? What do I expect? And then inspection is consuming these rules that can be scoped per delivery, and then flags the node where something is missing.
That's really excellent. That actually sounds a lot like exactly some of the things that I want us to be doing. So, Arn, we are going to gleefully poach as much of that as possible. And actually, on that note, Thierry provided that there's actually a blog post that CERN put up from 2018 about some of the high-level points of the hardware burn-in. And then there's also, y'all did a talk at the Shanghai Summit, which Tim just linked as well in the chat. I know we are running low on time. I'm personally going to go look at those because those are really interesting to me. And so I encourage other folks that are interested in that to take a look as well. We are about 5 minutes over. And again, I wish I had another hour for us to keep talking about this.
Although I've arrived with the hook, I've also arrived with some good news for everybody, which is that in 3 weeks, we have an entire 3-day event on hardware automation, in which James and Julia and many of the folks participating here are actually on the programming committee. I happen to know there's a whole section on hardware lifecycle management. So I'll let you get in the last word, but we are going to take a break in just a second. But it is awesome that our next event is all about hardware automation, and it's 3 days. It's openstack.org/OpenDev. You can register for it. So there'll be a lot of conversations in between online. We can all connect, and definitely you want to follow James and Arnie and Julia and everybody on Twitter. Arnie's always sharing incredible stats about CERN's use of bare metal and how they're doing it. So good conversation on Twitter too, but we got that event coming up in 3 weeks, hardware automation, to dive into all this stuff in more detail. So James, do you have any last words of wisdom here for us?
Last words are really just gratitude. Thanks everyone. Thanks for joining and sharing with us. I look forward to stealing as many of your ideas as possible and putting them into our infrastructure. I really appreciate all the collaboration.
Awesome. Great. Well, I think we're going to take a short break, maybe about 4 minutes. I think we're going to queue up the amazing music from the sounds of Aaron's playlist. So thank you, everybody. We'll be back in about 3 or 4 minutes to jump into edge computing. And thanks again, James, for the awesome moderation and everyone's participation. That was an amazing segment. Thank you.
Thanks, Tom.
All right, hi everyone. We're going to get back to our next session now. So I would like to introduce Shuchen Wang for moderating the EDGE discussion. Take it away.
Hi, hello everyone. Can you hear me?
Mm-hmm.
Sounds good.
Yeah, great. So let me share my Etherpad. Can you see my screen?
Yep.
Yeah. Hello everyone, welcome to join this session, and it's about the edge computing. So today, this session we have several topics. First one, we will talk about the edge stories, and we encourage people attendees to talking about your story about the edge and any use cases you know about the edge. And please, if you talk about your story and you introduce yourself first, and talking about which company you work with and why you look at the edge computing. And we can also talking about the typical use cases for different industries like telco, manufacturing, and financial banking, and others. And secondly, we will talking about the edge solution and what kind of software solutions you are using in the edge computing, and how and why you use it, any feedback from them. And for example, do you use Starless to build it edge cloud? And do you use the Cube Edge or K3S and others? And also, what's the biggest challenge for building an edge cloud? Do you meet some security problems and any problems on building a networking? And do you have the reliability issues in the networking? And how do you resolve the performance for the storage? And also, we have some discussion about the edge footprints. Do you need a small footprint for the edge devices? How to manage them? How to use the IoT solution to manage them? And third, we can discuss about the relationship between the edge and 5G. As we know, the 5G is coming, and countries are building the 5G network, and the edge computing bring up the 5G, or the 5G bring up the edge computing. How can we build a Mac platform to let the application to use the advantage of the 5G? And last but not least, we talk about the applications. do you know about the application innovations on the edge? Do you know about how we can leverage AI capabilities on the edge side? So that is the 5 topics I bring up in today's. And if you have some good ideas, you can also write down your interesting points in the Etherpad. So let's get started from the edge story. First, I can introduce myself, and my name is Zhu Quan. I work for 99 Cloud. I also the member of Starling STSC. I'm working from since 2011. I'm work with I'm involved in the OpenStack community, and also from the 3 years ago, I turned to the edge computing. I have knowledge on the enable the edge computing in the China here, many telco customers, and also bring up the edge solution to the different industry in China here. And I would like to share my story about the edge first. And after that, I hope the participants, you can share yours. One interesting story about edge from my side is that in last year, we built up edge intelligence agriculture solution to help the farmers to improve the productivities to bring up the shrimp. And as you know, the shrimp it has to it requires high precising and the healthy balanced ecosystem for the water. So traditionally, they leverage the human experience to tuning the ecosystem for the shrimp. But we built up edge platform just beside the farms, and it collect the temperatures and the many other through the sensors to collect many metrics in real time near the farmers and tell the farmers how to provide a more safe and healthy environment to the animals. And automation is also building us tools to provide these services to the farmers. So the farmer no need to have very deep understanding about those animals' habits. They can just use those the system near the farmer in the edge to build up a healthy environment for them. By this ways, we can improve the productions for the farmers. So that's the one story from mine. And anyone want to share the story about edge from your side? Maybe you can talk about, I see someone is writing the HPC, and do you want to share?
I can do. That was me typing in blue again.
Nice, Ron.
So from the HPC point of view, it's more that more and more they're getting very similar patterns of architecture, in the sense that you have experimental systems that are producing lots of data that need reducing. And then there tends to be a sort of federated network of clouds between different people in the center, if that makes sense. So it feels like a lot of the challenges that edge, sort of more mainstream edge, seems to hit, we're actually seeing in the scientific HPC kind of case as well.
And for the HPC, I guess for the edge side, you also build up consists of several servers, or just like the server form factor. It's not like those. It's not. It's built with maybe dozens of servers as an edge side, right?
It varies. It depends how big the equipment is. So, for example, in some ways, you could look at the square kilometer array and then said, well, I guess what CERN does is an edge, in the sense that you have several experiments with reduction in a local compute cluster, which may be racks of servers. but then that has a data stream that then goes out to the more, pushes it out to several data centers that then do the analysis. So you effectively, you kind of, in the same kind of way that you're reducing the signals down to send it to the central place to do the processing.
Do you install the like the accelerators in those servers? I guess maybe have the FPGA or GPU kind of devices, right?
Yes, it's a simple answer. It depends on the what processing needs to be done. But if, for example, you're doing you know, FFTs and things on signals to get the data out, then GPUs are quite good at that. It varies.
Yeah, I also see the +1 in the telco. I think right now telco is one of the major 2+1. The telco is building the 5G infrastructure, and edge cloud infrastructure is critical to the telco industry to build up the 5G. As I know, in China, like the China Telecom, China Unicom, and CMCC, they all start to build an edge platform. They will have their own standards, or some of them may leverage like the ETSI reference architecture to build up the edge. So someone want to share about the stories from telco?
I can share a little. This is Chris. I mean, yeah, I added the first two there. You know, radio software, it's deployed close to the antenna. It needs to be close to the antenna, and then you of course end up with lots and lots of sites, small sites which are deployed close to the antenna, where of course you have, you know, cloud technologies coming out. I mean, this is one area where there are a lot of different solutions, because being close to the antenna can require a number of different hardware form factors, which then require a number of different software solutions in order to make sure that that software is manageable and running on site. So that's a clear thing, a driver for the telco industry. And I think what we see is that there are a number of solutions and enabling virtualization and virtual software management and lifecycle solutions based on virtual software coming out in telco networks to address each of these site types, and that I think is an asset that the telco operators in the telco industry will have moving forwards. They will have, you know, this very fluid and very dynamic infrastructure working in a number of different deployment styles. I think that's something that we should be looking at, and we should be trying to understand. Okay, what does this provide as far as a platform for innovation when it comes to, as you were talking about, 5G services, where the softwares that are emerging that need to be close to device are starting to become available. How do we make sure that they can land and be used in the right way?
Yeah, thanks, Chris. It's a very interactive session right now. I'm Ahmed, working for SSE. We have a lot of use cases right now. Try to develop in Saudi Telecom as a edge. One of them, the PRN use case right now. We have a lot of challenges to implement this very digital signal processing as the edge. We start looking for some FPGAs to be implemented as a telco. As well as we have some CDN. Sorry, I'm echo myself.
So Prakash, yeah, following on what Chris said and the other gentleman from Saudi, the issue of what you call having a compute unit closer to the antenna, like RU, we call radio unit or remote radio head types closer to that. Essentially, because the traffic that comes both uplink and downlink at that cell site, whether it is a small cell or the macro cell, needs to go towards or uses CPRI, what you call Common Public Radio Interface. So you can say radio over the optical. And once that's done, that means you can actually keep a little distance. And currently the standards are like you can go up to 75 kilometer, 675 to 120 kilometer. So therefore the hoteling, we call it BBUs, that can be the, that's what is going on in the transport area. And then essentially that goes to the data center, which is our edge data center. So the play is between the BBU, the central unit, you split the BBU into RU and the CU,
Yeah.
the centralized unit and the distributed unit. And then the data center is somewhere in there in the centralized unit, or it can be in the in between. That is the front hall or the mid hall, which we call it. So the edge can be, the more important aspect for edge computing is the data center and the interfaces connecting it, so that we can build specific capability which are very, which can be for multiple radio units, or it could be for multiple distributed units, or it could be centralized. So that's where the whole of this real time, non-real time, and those aspects come into picture. So essentially one thing to remember is it depends on how much of aggregation we do, so much of computing will need capability there.
Yes. Also, I heard an idea is that the edge computing actually is combining like the IT and CT together, because as cloud computing is more focused on like the IT infrastructure, but like the edge computing, it will interface with like the BBU, CU, such as CT technology. So actually, edge computing also is a combination of the IT and CT. And so anyone want to share other stories about in other industry? I see some discussion on the manufacturing. Someone want to talk about the manufacturing?
Hi, Shishan, that was me again. Oh, someone else is speaking?
Yeah, okay. I'm Steve from Nana Cloud, and today I will share a Starlink X use case. The project is involved with Intel and China Tower. China Tower provide a data center. Intel provide servers and a NUC, which is a small server machine, and the Nana Cloud deploy Starlink X on servers and a NUC. China Tower has 2 million towers and 1 million small data center. China Tower plans to open up the resources of the small data center to OTT manufacturers such as iQIYI and Thunder, which is a Chinese company. It has already done technical tests with OTT manufacturers. Empowering infrastructure with edge computing is a key task for China Tower this year. The test, promotion, and technology selection are carried out by the technology department of China Tower, Beijing headquarters. And the China Tower provincial company is responsible for promoting the business. China Tower Shanghai company will be the first to deploy Starlink X. The Starlink X edge computing technology provided by Nana Cloud basically meets the need of China Tower, involving center edge architecture, security strategy, container platform, unified orchestration, and remote management, monitoring, etc. China Tower starts with CDN business and use lightweight equipment, and the NUC equipment provided by Intel mainly carries its CDN business and use container technology to achieve the isolation of different CDN vendors. The test mainly used the small data center of the China Tower Shanghai company as the hardware environment, and each provincial company deploys 3 to 5 units for technical verification. To sum up, these tests can scale out to the whole country if the result of China Tower Shanghai company test is worked out. So this is the story I meet in my project. So is someone have some questions?
Yeah, I heard. Just is Chris, you want to share yours or?
No, I was actually going to ask a question. How many sites are in the trial that are ongoing with the Starling X solution?
The first test is involved 2 small data center, and we have 6 servers in the environment, and we deploy one Starling X and 2 servers for central cloud and 4 servers for edge cloud.
Cool.
Thanks.
Cool. That's exciting.
Yeah, it's a great example to.
Yeah, it's a great start. I think.
Yes. Yes, and I think it's slightly different because I made the comment that I saw a lot of manufacturing use cases. For instance, these tend to be quite bespoke. I think is the word I used. Like they're built for purpose. There tends to be, a mining operation or a particular manufacturing operation, and then a collection of people get together and solve that edge use case. And I think what we need to start to do, I think, is actually reach out to those people and say, okay, share the things that you can share about that, because while most of these are bespoke, one can imagine there is a lot of commonality and a lot of things that we can bring out into common use cases that can help on, for instance, the manufacturing edge or whatever. It seems like an area that is extremely active today, but there's not so much coordination, especially on that infrastructure layer and the common pieces that kind of need to fall into place.
Yeah, I agree. For the manufacturing, actually, each factory, they would like to see the solutions to resolve their pain points. So they actually the infrastructure, there's one part, and the applications above it just more important to the end users. So I think the edge combined with AI application is more popular for the manufacturing. Just like as I know, in the cities around Shanghai, they they have a Fastile or many other or making the screen factory. They would like to see, for example, like the fault detection algorithm AI application combined with the edge infrastructure to improve their productivities.
Yeah, Prakash here. Yeah, I would like to add here something interesting. And the interesting part is like I've been working with IEEE, some of the groups, and there is some group called INGR with what they call deployment group, and they told me that the boxes at the poles, which is used for the traffic control, they need to be specifically secure. Yeah, they need to be secure. The boxes means it's an edge server, right? At the end of the day, smart city applications tend to use some kind of a form factor which needs to be sturdy for both the power availability as well as security aspects. It needs to be hardened. So they have some specification, at least in the US, which need to be complied with, so that it is secure. At the same time, traffic can be managed. So it's a kind of a very similar to what we have in vehicle to vehicle or vehicle to the infrastructure, like
similar to some
platooning. Very similar
gateway.
to platooning, like platooning or onboard devices to manage the vehicle to infrastructure as well as infrastructure for the traffic pattern. And so intelligent transportation system application I would put at the edge.
Yeah, that's also for small cell. It used to be called Muni Wi-Fi, but you know, a lot of the 5G stuff, the densification stuff requires that ruggedized footprint as well.
That's correct.
Yeah, it's interesting. It's kind of I also see these use cases in China here is similar to some gateway, have some security functionalities and some networking together, and it could be controlled from the central. Yeah, I think we have share many use stories, and also if you want to know more about the use stories from different industries, I encourage you to read the latest Edge Computing Group white paper. I put the link in the Etherpad. You can just click and take a look at it. There are many use cases, and you will find someone you're interested.
That brings an interesting question. How do you deal with the energy? Are you using DC more popular in edges, or is it more of a AC in terms of power?
I guess both.
Any advantage of using DC over AC power, or?
I think the power and save energy and it's different, but actually here I see the both cases.
I think the telcos prefer DC just because their infrastructure is typically DC. So.
No, but does it mean that you can get the solar power on the field and have a converter, or you use directly the DC power from the solar?
You are asking?
Yeah, I'm asking, in China Mobile, are you finding solar energy being used as part of the edge?
Many of the points they are used just AC, and some pilots they are trying to use DC right now, but both cases have also existing.
Okay, thanks for that.
Mm-hmm.
So I have another question. Do you see much power over Ethernet on the edge requirements? It's just a general question for the group.
You mean can you say that again? The DC more general, or?
Yeah, just is there a use case for using PoE at the edge, power over Ethernet?
PoE,
I guess.
Yeah, PoE. Yeah, I'll get some more.
PoE is mostly on the switches, right?
Yes.
They are on the switches, not on the host servers, right?
No, not on the servers, but on the switches, right?
Mm-hmm.
Yeah, maybe for video surveillance use cases that we need to
potentially
bring up the camera.
What about the VRANs?
VRANs actually.
VRANs, it will be hosted on in the COTS, commodity of the shelf server. So there is no need for there is no PoE on the switch as far as I know. The server, sorry.
Well, I'm asking if there's a use case for it.
For the VRAM, right? Actually,
right.
there are a lot of pilots in the VRAN, CRAN, the kind of pilots, but in right now the 5G constructions, I see some cases in the pilot right now.
Mhm.
As you know, the 5G is still not in production right now yet. It's a lot of architecture is NS8 and building a lot. It's still building the SA pilot, and I guess for this SA architecture go to production, it will be the late Q3 or Q4.
Right. Okay. Because I could also see it for IoT devices as well. That it would be useful.
Okay. Any more questions? Let's move on. Next, we will discuss about the edge solutions. So we just mentioned, I heard someone talking about the Starling X. As you know, Starling X just get confirmed as a confirmed project in OpenStack. And actually, if you use Starling X, it only resolve part of problems in the whole edge. And Azure has more than has a lot of problems we need to resolve, and Starling was providing the infrastructure. And if we want a better like the orchestration layer or connect to the like the OSS, DSS to the that kind of system of telco, we also need to build other systems to combine them. And also, if you need to have some like the DNS handling or some API gateway functions, then we need to combine with other solutions. So anyone want to share about how do you use the software or solutions to build up your edge solutions?
Yeah, for the edge is very special requirements, and we always mention here that it's very small footprint. So regarding the architecture, I will refer to the white papers that you mentioned right now in terms of solid, two solid architecture that can be implemented right now in the network in terms of distributed compute node or centralized controllers. So these two approaches and architecture can totally fit the edge in terms of very small footprints that can be extended into any numbers with centralized control plane and just remote compute that can fit the use cases that we mentioned right now in terms of telco and non-telco use cases.
The small footprint is like ARM devices or x86.
Sorry, Sean, again?
Yeah, I mean, you just mentioned the small footprint devices. What architecture it is like the ARM devices or x86 devices?
Yeah, I could speak on that. Yeah, we're using x86, but we have looked at ARM devices. We would like to, but the software doesn't really support them.
Oh.
Yeah.
So why you consider the ARM devices? Because the
cheaper
power? Or...
Yeah.
Okay.
Cheaper, smaller footprint. Yeah.
Mm-hmm. Yeah, cost and power. Yeah.
Beth, do you consider to like the data center service replace ARM devices?
Good question. I don't know.
Yeah,
it's
actually,
cheaper.
Especially with Apple switching to ARM. Yes, sure, why not?
Actually, as I know, in China, many big telco company or many other company, they try to switch to ARM, but actually a lot of cases are just pilot cases, and evaluate the performance of ARM and the comparabilities of ARM devices like the software, but it is evolving, I guess.
It's very much evolving. Yeah. Yeah. I was the ARM folks. I attended a presentation. Was it last year? What they're doing right now, and you know, it looked pretty good. You know, but the software is still lagging. Right? So,
yeah, is there people from ARM here to attend this session?
Yeah, I don't know.
Linaro is there if you obviously, but still it requires a lot of hand holding.
Yeah, I'm not saying anything against ARM. But
yeah, you're saying the truth.
yeah, just saying the truth.
Yeah, understand. Yeah.
Just a question: which software do we see as lagging? Is it the tooling? I mean, the OS is there, of course, but is it the tooling or the applications?
The applications.
Because they're not just Linux native, right? They build against particular CPU architecture. Yeah.
Exactly.
Yeah, I see
So much
someone
for
draw.
cloud native. Okay, sorry, Sean.
Yeah, sorry, I just read the message. Someone draw questions in the chat. He want to learn more about the telcos and internet service providers design. I suggest maybe you can read the white paper from the Edge working group. We have 2 white papers. The first one is, name is extend the data centers. It will explain you they have some descriptions about how telco build up the edge platform and what the edge cloud computing is. And the second, it will talking about the architecture designs and testing, and you can take a look at it.
Well, that brings up a question, because the person who wrote the note said data centers, and I know there's a lot of confusion in the edge world about what is edge. And I personally, I break it into 2 pieces. There's the edge that's a couple racks, and then there's the edge that's a couple boxes, and the requirements for the 2 are radically different.
Yeah. I think from my understanding, I can treat different from the the network latency. There are different edge sites, like the access layers or aggregate layers or the data center layers. So different edge sites, you have different scale, and IoT may be the end for the edge sites. It's just small boxes. Could be
right. Those are the gateway, the IoT gateways.
Yeah.
Which are small boxes. Yeah.
Yeah. And also, I see someone write a face recognition. So, do you want to share?
Yes. Hello, my name is Chen Yu from 99 Cloud. Today I will go sharing an edge solution that combines Starling X infrastructure and face recognition. As we know, the Starling X is a complete cloud infrastructure software stack for edge used by the most demanding application. It is good at managing distributed cloud. In this case, I use some Starling X feature like a scalable, small footprint, ultra low latency. When it goes to face recognition, we have to train the model by neural network and other else. We train an AI model in a data center with a bunch of GPU and cost a lot of power. Cost a lot of power. In this case, the data center is the central cloud. First, we prepare a central cloud which has some management service like configuration management, host management, fault management, and software management. Those will support central cloud to deploy and management edge cloud. Second, we deploy an OpenStack infrastructure on edge cloud. The OpenStack service will create some virtual machine to handle its own project. In my case, we prepare an image with well training face recognition model, and OpenStack will use this image to create a virtual machine. As the face recognition image do its part, Central Cloud can collect the data from the edge cloud to do the analyze and research. Besides, we can do the image upgrading from version 1 to version 2.0 in the Central Cloud and push this new image to the edge cloud. The total solution is what I sharing above, and the most benefit is we do the hard job in the data center, like training model, like analyzing in the data sorting. And after we build a new or make a new training model, we just make it an image and push to the edge cloud. This will make the low latency. And the edge cloud, actually the face recognition, we need a camera. The camera can be put on some IoT box like a Raspberry Pi or some small computer. And it is even easily to do some flexible and scalable deployment. For example, if we deploy on a industry, and based on each scenario, we can put more or less the device, just depend on what we want. Thanks for your hearing. Thanks for your attention.
Yeah, this is interesting. It combined with the Raspberry Pi. And okay, let's go on. For the biggest check. Go ahead.
Is this 99 Cloud person Chengtai, right? Do you use this for security systems for identifying the individual, or is it more of a experimental at this stage?
Excuse me. You say that I use the identification
Yeah.
management
Is it for the identification of the person, or is it more like experimental right now?
Or just put it on to recognize the person's face? Yes.
Yep. Prakash here. Yeah. Oh, so okay. So you are identifying the faces you are seeing. Okay. Thank you.
Thanks.
So since you're using the pre-built image, so the image is the one which also includes the programming of the GPU for that, or using like Cyborg or some other way of configure the flows through the GPU?
It doesn't matter. It just as we build a training model, training our own face recognition model, using the GPU is more convenient, but we can't put a GPU or other more high performance equipment on the edge cloud. It should be done in a central cloud.
I understand that. It's more a question of how do you do the separation of the application from the underlying platform, and that's the question. Do you is a part of the application you configure the hardware, GPU for that, or you use some programmatic way such that platform and the application are independent from each other?
Oh, okay, I understand. I will think later, and I will
maybe
respond
look
as soon
at
as possible.
are you using something like OpenVINO library from Intel for the hardware? If you are using Intel, if not, then any other library
No.
specific?
No.
I guess this application leverage the OpenVINO, right?
Oh yes. Use
Yes, it's for application.
Neural stick and use the OpenVINO.
Okay, that gives a clue how you're
So
doing.
so by the OpenWindow can adapt to different platform to use it, the accelerator also, right?
Correct. But you do it programmatically instead of the hardwiring. That was a question.
Sure, that answers.
Yep.
So the next question is, what's the biggest challenge for building an edge cloud? I think the networking is all three have 1+1, and do you want to share? Anyone want to talk about like the security here?
Yeah, that was me that put all those 1+s. So security is because you don't always have control over that edge, right? If it's out of a data center, if it's on a light pole, we talked earlier about ruggedized. Security is also an issue as well. You need to be able to, if somebody gets onto the box because they have physical access, that they can't do anything. So there's a lot of dimensions to the security needs. Storage, of course, because again, there's a limited amount of storage. So you also, I know at the PTG a couple weeks ago, what came up was a long discussion around persistent storage, because again, you don't have, if you lose network access to the device, you need to be able to restart it. So you need some kind of persistent storage. It can't all be in memory. And then there's also a lot of use cases for moving storage to have stuff out, in storage, particularly CDN is an example where you want to actually have data stored out at the edge. And again, not in memory. And of course, we've already talked about the small footprint. So.
Great, and I would like to share about the networking. As I said, the telco building the 5G and the MEC platform, they have to connect to the 5GC. So the networking is very complicated. For example, like the UE, they have to connect to different the UE has to go through the different controlled commands and connect to the MEC, the data flow going through the MEC platform and go back to the networking, and how the MEC platform connect to the UPF, and how how those different components building the network topology, and also
and
how to monitor. Yes, and the network slicing, that is very complicated. And different telco and different companies have different strategy, and they have different catalog for the customer and target industry that's different. So different needs for them. So I guess the networking is, I think it's the biggest challenge for me.
Yeah. In terms of, I'm just need to emphasize here regarding, we need to be more conservative about the terminologies that we use. I'm always mentioned in many, I work with this in the CNTT edge work stream. So we try to put it in, not every edge deployment is a MEC or MEC. So when we use MEC or MEC, it is ETSI MEC architecture with some solid architecture and some defined APIs. For the edge itself, for sure, the WAN latency, one of the aspects as the challenges regarding the networking inside the edge pod or POP, one of the most challenging parts, especially if we use multiple use cases, maybe VRAN and CDNs and AR, VR, gaming, all this stuff, and we need to have certain service chain use case across multiple functions. So we need to extend maybe some SDN stuff at the edge. So which I believe is very complicated. And if we're looking for more containers, container infrastructure at the edge, and we need to extend the container network interface to be extended to SDN or something like that as well, it makes our life more complicated. So the edge networking as the edge is very challenging points that we need to take care about this about this challenge.
So that brings me to China Mobile did present, Lingli Deng did present in the ONAP the network slicing, and they focused on the core side of it and core transport and the radio side. But I never heard about that edge being included there, but that's because it will probably be in between the transports if I push it that way, or on the either side of it. So yeah, go ahead.
Yeah, thanks. I think I saw this slide in attend this session maybe. The point here regarding ONAP, we can onboard end-to-end service touching the transport, touching the edge, touching the core, but to extend or to make networking extending from the core to the edge, maybe it is not such easy task, as that need a lot of implication. Especially we are looking for again small footprint, maybe cloud container infrastructure should be deployed at the edge, as one of the points that we wrote it here as a Q3S or Cube Edge. This is container infrastructure based. So if we need to have more networking facilities and power of networking, it would be this platform it will be challenging to us to achieve what we're looking for.
Yeah, but Cube Edge is definitely a good work done for the edge deployment. Essentially, we need, if we have somebody talking about Cube Edge, we would appreciate.
Cube Edge is considered a seed project for CNCF. It's under CNCF consortium. This seed is invented from folks from Hawaii, and we have discussion during couple of activities during LF Age and all this stuff. They have blueprint with Acrene right now through Cube Edge Acrene blueprint. But personally believe it is not commercial or telco grade deployment that we I'm presenting telco here. So for the telco deployment, I think there is a lot of challenge to make a Cube Edge as one of de factos or one of architectures that we can depend on it as such this time. Yeah, maybe down the road can be evolved more and more. But right now, I am assessing it, and it's not capable to fulfill telco grade applications that we are looking for as edge. It's my insights.
So it's a use case issue. You need
Sorry?
to identify the right. You need to identify the right use case. You're saying.
Yes. And by the way, the edge concept or the edge story, it is as I'm always mention that it is use case driven, and no one size fits all. So whatever use cases that you can put Cube Edge, you can put the Q3S distributed architecture, centralized architecture, all in one, Starling X. So you need to figure the use case first, and the vertical that match this use case, and looking for the infrastructure that can achieve this use case for sure with low cost, and avoid the challenges that we list here: challenges of networking, storage requirements, image handling, all this stuff.
So it is a functional capability, right? Like you have for the video, you have OpenVINO. Similarly, we need some software for the sound, text, and those kinds of media recognition and encryption, decryption that are required at the edge to either to do it at the edge or to defer it to the cloud, like you mentioned about the VM in the not you, but 99 Cloud mentioned. So I think Acreno has got hundreds, not hundreds, at least 20, 25 blueprints. And I don't see all of them being active now.
Yes.
And only some of them have spanned out because they have real use cases.
No, there is a lot of.
Yeah, go ahead.
Yeah, I think there's active. Yeah, there's active blueprint under Acreno, like network cloud, which is hosted by AT&T, and there's a lot of networking part covering in network cloud blueprint. Right now, we have we work with the Acreno team in terms of 5G edge use cases and some sort of test platform as a service, and how can we expose 3GPP SA6 APIs to external developers to start to develop certain use cases. Personally working with Telco Edge Cloud under GSMA, so we have some sort of alignment to utilize this effort as well. So I will repeat it. It is use case driven approach. Whatever use case you have in your hand and you need to implement, you will find the way to implement it.
Yeah, but none of them still haven't been a killer application in the edge. That's the challenge we have. We don't have a killer application as such. It's all distributed.
Yeah, we don't know the killer application because 5G is not it's just coming. It's not built, and just like we don't know the killer application for 4G is not actually happening. So maybe we can discuss what's the application for 5G and how to optimize for that.
Based on the stats, it is the video which is the killer. But still, video has got so many streaming applications. We really can't get to one specific video use case, which will make it.
Yes, the short video app is very popular right now in 4G, but I think like the AR VR application may be more popular for 5G. Right now, the AR VR require more low latency and high bandwidth, which the 4G network cannot provide it. And if we get better experience in AR VR, as we all know, it requires lower than 20 milliseconds. So I think that will be more is a very popular application in 5G networking, but I don't know if it's the killer application for 5G. That's my point of view.
Is gaming not so popular? AR VR is one, but are the gaming like we had yesterday present gaming for the large scale applications by Bizarre? That was the LA company. Do you see gaming in China picking up a lot?
Yeah, I think gaming is should be one of them, and because as we all know, the gaming has huge customer, huge users, especially for the young teenagers, and beside that, I also see like the sports or entertainment is very popular, including gaming and short videos and sports. Like the sports that the AR VR give the immersive experience for the people. Like you watch like the basketball sports or some F1 games, they will have better experience. They have to leverage the 5G network and the MEC platform to implement that.
Interesting.
Yeah, and from my personal side as well, why we always mention Xscaler application. Right now, the telco right now looking for some monetization of the edge. So if we have a very business case and use case like gaming, and we can build this edge and starting to cooperate with any gaming company, EA or something like that, and we try as a telco monetize this edge deployment, it will win-win situation. There is no no it is not about killing application. We can work in win-win situation, avoid killing actions, and we can work together.
Yeah, I was quite curious about what was the people from like the North America or Europe, what's the point of view about the edge application? Can someone answer that?
From North America, what we saw is gaming is definitely, like yesterday it was pointed out, gaming is one of the more popular applications, especially with the younger kids. And from other use cases, is one of them is utility, like metering, net metering, both power as well as meter reading for the supply, water supply, and various other utilities. Those are really good ones as we see in North America.
Great. Yeah, I see the time is up, and thank you everyone to join this session. And I think this is today. Thank you.
Thank you.
Thank you, guys.
Thank you for managing.
Thank you, guys.
Thank you so much.
Yeah, thank you so much, Yushen. That was great. All right, well, next
you.
I think we're going to move on to our wrap-up section, so I will let Sparky Collier jump in on that.
Yeah, thank you so much to everybody who participated in this session and the previous session, all of our moderators for this whole week, to really take us into the wrap-up for what we've been discussing all week. Jonathan, Bryce, and Tariq Perez are going to take us in there, and the moderators throughout the week, feel free to jump in as well and participate as we go through some of the stuff we've learned and how we can get engaged post-event. Take it away, JB.
Thank you. Yeah, so I just also want to say thanks to all of the moderators for leading these discussions. You know, these were quite large virtual discussions that we were having with you know, 100 to 200 people over the course of the week, and that I would say is not necessarily a kind of a normal type of panel to lead when we're doing that virtually, and you know, that's, I think, a really great job on the part of all of our moderators. So thanks for that. I have an Etherpad here for the wrap up. You can maybe drop that link into chat while I get it shared. Okay, people able to see this?
Yes.
Okay, cool. So I wanted to maybe start off and ask if anybody had any feedback overall on the event this week. As we've mentioned several times, this was event 1 in the series. We have 2 more coming up on hardware automation and containers in production, and so would love to get your feedback and any comments that the attendees and moderators have, so as we move forward we can keep improving them and making them even better.
Yeah, Prakash here. I'm really impressed by the OpenInfra Labs, which is a new initiative, and look forward to working with you, Jonathan, and others who are in the team. And it's a real good one for the future. That's my comment.
Yeah, great. Well, thank you. Yeah, I think that that's going to be a pretty useful project as it gets going, and really is relevant to a lot of the different topics that we've covered this week. Any other comments or feedback? Well, there is an Etherpad link in here as well, which if you think of something, if you have any other thoughts or tips that that you would like to send our way, then you can go drop them in that Etherpad, and we'll definitely be taking a look at that. You can also email events@openstack.org, and we'll follow up there too. So getting into some of the wrap up of the week, I talked about some of my highlights from the first and second days, and you know, if any of the moderators are on, if you have any takeaways from your sessions, it would be awesome to hear what you thought were the highlights from the discussions, or anything that might be worth adding to potential follow-up activities. We have any moderators that want to get back on for a minute?
I thought I really liked the collaboration from everyone that was jumping in and chatting in all the sessions I attended. I don't know, I think the only thing I would say is, like, if there's a way to get even more people talking, that'd be great.
Yeah, I agree. I think today we had a lot of great interaction, and maybe it just as we do it a couple more times and have some more people come back in, then I think that's going to be a way that we get more of that interaction as well.
Yeah.
Any other comments?
I'm quite excited by the reboot of the OSOps tools. There seems to be some definite feeling that more people want to contribute their one-off scripts. So that sounds hopeful. I say one-off scripts, it always feels like it's bespoke to you, but then when you have these conversations, like this week, right, you go, oh, actually everyone's got exactly the same problem. Well, there's loads of people with a shared problem, so that's cool.
Yeah. One of the things that I thought was interesting along those lines is that it seemed like when we got into, there were a lot of questions where the answer was it depends. And I think that because that is often the answer, then you may not want to sort of like share the specifics that because like it feels like you arrived at that because of your unique scenario, and in reality a lot of other people are in that scenario. I think the OSOps discussion yesterday and the upgrade discussion to me were really kind of very obvious examples of that to me, where we probably have a lot more commonality than we realize, especially I think at this point. OpenStack and Ceph and Rabbit and all of these things, they're highly configurable, but after years of usage, it seems like there are some patterns that have really started to come together.
And it's also very difficult. Sorry.
Oh, go ahead.
It's also very difficult to see what those patterns are unless people start to share their experiences. And so it feels like you have this unique case, but once you start sharing, you realize that others have variations on the same issue. And once we start sharing and collecting those experiences, we're able to document those experiences in a way where, like, the next person will be able to realize that they have much more in common. So it's really more like a snowball. And as we start sharing, we realize that we can build something better for everyone by just having more people sharing their story.
Yeah, well, I was going to say that along those lines, I think that that one of the things that I'd love to do for a few minutes here is and it looks like it's great, some other people have added to the follow-up activities list here. I would love to see if there's anything that we can get kicked off. You know, maybe we'll things that we can mention in like the follow-up emails that'll go out after the event. Yesterday I talked about how I thought the discussion around the planning and the strategies of upgrades was something that that could be pretty valuable. Is there anybody else that is interested in that? I see that there's potentially an opportunity to leverage the large scale SIG for that. But are any of you who threw out tips and tricks around upgrades yesterday, would you be willing to participate in putting together some docs around some upgrade planning and strategies? Yes, this is great. Share your name here. Again, I think that one of the things that stood out to me yesterday is even though there are different deployment tools that people are using and different methods for managing the life cycle of their OpenStack environment, it seemed like some of the things around validation and testing and rollback and planning and those kinds of things were probably really valuable, especially you know, for some of the OpenStack users who maybe haven't gone through an upgrade cycle yet. Well, add your name in the Etherpad around line 14 if you are interested, and I think that that's a good one to carry into the large scale SIG. So John was just talking about the OSOps tools. I thought that also was interesting and exciting to see bring up. There's a wiki page around this already, and there was kind of a proposed structure for how things could move through. And I think this graph, I had kind of forgotten that this was on here, but I was looking at it, and I think it speaks directly to what we're talking about with like bespoke to me kind of tooling. But the idea with the OSOps tooling is there's a contrib repo that is really just about sharing your tool and putting that out there in the open. And if it's something that other people use or not, that's not really kind of the primary goal at the contrib level. It's just to kind of share the knowledge and share the tool that you have built up. If the community sees that this is really useful, broadly usable, and something that is kind of a more generic thing, then it can go into a different repo for you know the kind of generic tools. So I think that there are a few different kind of like models for sharing within the OSOps repo, and there's some documentation here around that. But I think that it would be great to kick that off again. Who has been involved in that? I know Eric McCormick was on yesterday. Looks like he's not on now, but I know he was on yesterday and talked about it a little bit. Is there anybody who is still on the call that was involved in OSOps activities before? No one. Okay. Well, now's your chance to join in. Yeah, this might be something to hit the mailing list with, and maybe I'll reach out to Eric as well. And also, I think that you know, for the OSF team, this would be a good thing for us to perhaps promote and mention in some of the upcoming newsletters if we see that there's actually some interest and a kind of like a renewed level of activity around it. A lot of those repos, if you go look at them in OpenDev, it's been a while since they've had activity, but I think that you know, that shouldn't stop us from from going back there and revisiting the idea. Okay, let's see what else is here. So OpenInfra Labs, Prakash mentioned this one, and I said that I thought that there were quite a few areas where the OpenInfra Labs activities could be relevant. They're the kind of initial environment that is getting built out across the Massachusetts Open Cloud universities is an environment that's incorporating all of the common open source software that we've been talking about over the last few days. So it's OpenStack, Kubernetes, Ceph, Prometheus. There's bare metal management in there with Ironic and some other things that are that I think they're looking to get upstreamed into Ironic. And what's great about it is, you know, this is an environment that's actually live. It's running real workloads for these different research users, but they are committed to basically following along very closely with the upstream projects that they're deploying. So I think that there's a really great opportunity to see kind of how all of these projects interact with each other and integrate, and get feedback into the upstream development communities, but also share operational knowledge and experience from those as well. So
Jonathan,
you know, glad that we had them on. Yes.
Jonathan, do the meetings for this also go along with this large scale Wednesday meetings, or is it different for them? Open Lab, Infra Lab.
OpenInfra Labs has they have some other meetings that they do. They are on IRC. If you go to openinfralabs.org, they have kind of the ways to engage in the community. But they're on IRC. There's a group already in a channel there called, I think, OpenInfra Labs. And they do have some regular meetings. I know they've been doing a series on monitoring, which is been pretty interesting to follow as they've tried out different monitoring tools and have been working to get different metrics out of these open source services.
Yeah, some of the terminologies there still are not clear on the architecture, and so yeah, I'll probe into it. But essentially, it's a good one to pursue. On the Wednesday meeting, it's a IRC only meeting, the ones which you are talking about for the large scale. It's mentioned IRC Wednesday. OpenStack 3.
So sorry, which meetings are you talking about? They have there is an OpenInfra Labs meeting that I think has generally happened on Wednesdays, where they have talked about just different topics within the environments that they're building. That's separate from the OpenDev series that we kicked off this week. It has specific topics, and this week's was large scale.
I see. Okay, I'll follow up offline. Thank you.
Okay, yeah. And speaking of large scale, Thierry, maybe you can talk a little bit about the OpenStack large scale SIG, and see if anyone wants to join in on that too.
Yeah, sure. So the large-scale SIG was formed to facilitate running OpenStack at large scale. We had various groups tackling that issue in the past, but that was a new reboot of the various initiatives that we had before. And the goal was really to get operators of large-scale clusters to share their pain points, their stories, and try to detect what are the early limitations that operators encounter when they scale up, so that we can help feedback into development solutions for those first bottlenecks that clusters get when you start scaling. So identified two goals for the SIG early on. The first one was pushing back the limits that prevent scaling within one single cluster and instrumenting the bottlenecks. So basically, when you have a single cluster, you don't do any availability zones or any cells to scale further. What are the first things that you run into that prevent you from scaling? And a lot of people will answer RabbitMQ falling down at this point. And so we've been starting to work with Line, especially for them to publish the code that they are running internally to instrument RabbitMQ, which allowed them to shard the RabbitMQ deployment that they had in very efficient ways to pass that bottleneck. So it's a good example of the type of things we're trying to do, which is extracting the knowledge that is inside those large-scale operating companies and push it back into the commons so that everyone else can also benefit. The second one, which is driven by Arnaud Morin from OVH, is to document the configuration options from a large-scale perspective. By default, the OpenStack documentation is talking about default values for configuration values, and sometimes those defaults don't work well at scale. So it's good to know which configuration options make sense to be tweaked at scale. And so that's also an effort that is ongoing. We rely on experiences of various people to build this new documentation. So we had the feedback from CERN, we had the feedback from Line, we had the feedback from OVH, but it's not enough to build a comprehensive documentation on configuration issues that you will encounter at scale. So we welcome new people to the large scale SIG so that they share their stories, share their configuration files, share how they solved some issues that they had, so that we can produce that documentation and go forward. So those were the two early goals of the SIG, but obviously after this week we'll likely have new members joining and potentially pursuing other goals like documenting upgrade issues or potentially working on other large-scale type issues. It's really a forum for operators of large-scale deployments of open infrastructure to come and share their problems and their solutions so that we can all solve issues going forward.
Are there anyone using Kafka for instead of RabbitMQ for OpenStack?
Well, there are people using Kafka, but they are not coming to the large-scale SIG yet. So I'm willing to welcome them.
Yeah, if you find some people, we would like to see them. Yeah, sure. Thank you.
And I should add that the next meeting is next week, so it's perfect timing for a follow-up discussion from this week. Wednesday, it's currently Asia Europe friendly time due to our members being mostly in Japan, China, and Europe. But if we get a lot of participation from the US, we'll likely set up more of a rotating time for the meeting so that everyone can join in.
I was about to say, it seems like the next meeting is well timed. So, James, you were going to add something?
Yeah, I'm gonna try and start joining this. I think those will be really useful for our folks.
It's I think it's 1 a.m. your time, so.
Occasionally, I might join.
You can handle it.
But it'll be worth it. It'll be the best 1 a.m. meeting you've had. So speaking of James, bare metal, I was going to say, it seems like a important follow-up here is the next OpenDev is all about hardware automation. And I thought the bare metal discussion this morning was super interesting. And really, it seemed like there was just way too much information to share. And so it's good that we have a another event coming up. I especially around the life cycle stuff, I thought that was there's a lot of potential there. And I believe that we actually also have had a group working on a plan white paper that is going to get published. And I don't know, Allison, what's the plan? I'm going to put you on the spot here. What's the plan around the bare metal white paper that's been worked on by a group there?
So the draft is really far along. It's incredible and it's pretty lengthy. So we are in a review process now, and then we're going to circle back with the bare metal SIG on next steps in terms of publishing. And so honestly, that's another SIG that is worth checking out if that discussion today was particularly interesting. That group is definitely very active. I'm hoping that we can publish the white paper in the next month or so, but we're in the review process now. But if you're interested in getting involved, please reach out and I can drop a link in the chat. I know there's a few folks on that are a member of that group and who have helped with the white paper. So a huge thanks to those folks. It's really incredible, it has a lot of use cases. I think it's like 31 pages right now. So it's definitely a lot of work that's gone into it. So huge thanks to those folks, and keep an eye on the OpenStack Discuss mailing list, because it's probably going to be one of the first places we hit when we publish it.
Cool. Yes, I think that's like Allison said, a lot of work went into it. And I think it's going to be a really good resource. And I wouldn't be surprised if we find other topics to dive into and create white papers or materials around after the next OpenDev event.
Yes, it has come long way. The white paper has come long way from what it was probably 3-4 weeks back. I think a lot of editions, people have done an excellent job, actually. We need to put a closing on it, but that's the most important thing.
Okay, and then the final session that we wrapped with today was around edge computing, and again, really interesting. You know, it was nice to hear a lot of different topics that were touched on, and thanks Shuchen for moderating that. And I thought we were able to get a really broad set of input there. Wanted to point out that there is an edge computing group, and I think that they just finished the second white paper that they have. We heard about Starling X a couple of times, and some use cases that are in progress there, which was also exciting. 2 million cell towers in China. Sounds like a lot of cell towers to me. But that was great. One thing that I thought was interesting that was flagged in a couple of sessions was how networking was flagged as a challenge. And it made me think that maybe there's some follow-up that we should do around networking specifically. I know we had the HA networking session yesterday, but maybe even just non-HA networking, just networking in general might be a topic for another session, as it seems to have been a pretty common challenge that people are running into. So any thoughts or input on that?
Hi, Jonathan. This is Shu Chen. Can you hear me?
Yes, can hear you.
I think working is as I mentioned is strategy I think and I thought of for
Shu-Chen, you broke up for me. I'm not sure if that was just me or if.
Yeah, you may want to drop it in the chat if the audio's having issues.
Okay.
Did you hear that? Was it?
Yeah, I can
now
hear
you're
you,
clear,
but maybe. Okay. Yeah, the poor network. Maybe it's late in here, China. I mentioned maybe we should draw more attention on the 5G and the edge and how the how telco build the edge platform to implement their 5G construction target.
Okay.
Yeah, that's the point.
Okay, yeah, that's a good one. Yeah, it seems like you know, the more that we have been able to get people engaged, the more just really interesting information that we were digging out and that I wanted to dive into even more. So I think you know, it's a good sign, and we'll have to keep some of these events going over the long term, I think. So those are the follow-ups and kind of the highlights that stood out to me. What did I miss? Does anyone have anything that they want to add in? Any other points or suggested follow-up groups or activities or anything like that that maybe I didn't mention? Going once, going twice. All right, so final thing to wrap up with here. As we've said, you know, this is the first in our OpenDev series. The next one will be in 3 weeks on hardware automation. So that's going to be July 20th to the 22nd. And this is, I think this is going to be a really exciting one, talking about all kinds of hardware automation and really basically how do you deal with all the stuff that's in our data centers out there. You know, as much as we like to virtualize and containerize, we still have data centers full of physical matter that we have to manage. So that's going to be the theme and the topic for the 3 days starting July 20th. And then a couple weeks after that, we will have containers in production. And this is a topic that I'm also really excited about. I think containers have been really hyped for years now, but we're seeing quite significant production usage in a lot of different areas now. And I think that as that happens, you know, people find issues with networking or security or configuration management, and so August 10th to 12th, we'll be talking about those different topics and those issues. So you can register and join us for those at openstack.org/opendev. And then we are planning our Open Infrastructure Summit, which is scheduled for October 19th. And we have just opened the CFP for that. So you can go to cfp.openstack.org. You know, that will be an event that has more presentations. So that's going to be more of a traditional type CFP here with speakers and slides and you know, that kind of presentation versus our very dynamic discussion style like we've done for OpenDev. So if you have topics or use cases or you know, anything you want to share, you can go submit your CFP at cfp.openstack.org. So I think
Jonathan,
that is it for my wrap up. So I was going to hand it back to, well, I was going to hand it over to you. So perfect timing. I'll give it back to Mark and Ashley to finish up here.
Cool. Yeah, well, I was just going to say something about the events while we're on this topic, because I just want to say thank you to Aaron and the whole OSF events team. These events take an incredible amount of work behind the scenes that not everybody sees, and moving in and taking these events virtual was not something we expected heading into this year, but it's been great to see everybody adapt and learn all the new tools and figure out how to configure Zoom. So thank you to the OSF events team for putting on this event this week, but also they're already diving in and working on these 3 other upcoming events. So just want to say thank you to the events team at OSF for everything they've done on this. And then I think Ashley, if you have any last comments on this event, we can wrap it up.
Nope, I think you said it all, but thank you again, everybody. And we look forward to seeing you at the next couple events.
Sure. Yeah, I hope you had a good time with OpenDev.
Prior to that, on the tracks, you got multiple tracks. Can somebody be nominated for 2 tracks?
Sure, they can. Yeah.
Is this a summit question?
Yeah, that's a
CFP?
because you got NFP, 5G, and then you got the AI/ML and so on and so forth. So
yeah, feel free to send me an email about that precaution. I can.
Sure.
Yeah, appreciate your involvement. Everybody helping us put together that summit coming in October, and as well as these other 2 events. So it's going to be great.
It's not going to virtual, right?
Yeah, so the summit, we have not specifically rolled out the details on how we're implementing it. The original plan was to have it in Berlin. So right now we're at the stage of just opening up the CFP and getting the presentations in. I think that, in the next couple of weeks, we'll be able to share more about how we're implementing it. So I think it's likely it will be virtual for obvious reasons, but right now we're just focusing on the stage of getting in all the great topics and folks that want to help with the track chairs and all that stuff. But good question.
Thank you.
All right. Well, I think that's it. So thanks everyone, and join us in a few weeks.
Yeah.
Thanks, everyone.
Thank you.
Thank you. Bye-bye.